Hello guys, this is DCC. In this session we are going to see about what is CATIA and what are the features and what are the uses of CATIA software. CATIA is known as the computer aided 3D dimensional interactive application. Okay, it is a computer aided designing software which is owned by Avian Marcel Dassault Systems. Okay, they are the parent company of CATIA. It has been first released in the year 1977. It is also used in aerospace and automotive, shipbuilding, and other industries. Okay, where the heavy components are used. Mainly in automotive and aerospace industry, the CATIA software will be used. Okay, let us see what are the features which can be done on CATIA. Okay, this is the specification tree. If you open CATIA means the first thing we are going to notice is the specification tree on the top left corner of the software. Okay, it provides the access to the history of how the parts were constructed and show the product structure. Okay, what they mean to say is how we are going to create the parts. So if you see here means in the print in this part named as print, there are three basic planes, and this is the part body of that part, and the part body is made up of first they have used a pad operation. First they have created a sketch, and then they made a pad operation. Pad operation is nothing but your extrude operation to create the 3D objects from 2D objects. Okay, if you use pad operation means the 2D objects can be converted into 3D objects. Okay, and there is a hole present in the in that extrude operation. The extruded part, there is a hole present. That's why it has a second command of that hole. Parts can be modified by selecting them from the specification tree. If you want to modify the hole, or else the sketches which controls the hole means you just have to double click the sketch, or else the hole we can modify it easily. Okay, the next thing we are going to see about what are all the modules we are going to cover in the CATIA software. First is the sketcher module. Sketcher module means the things which we are the things and tools which you are going to use for the sketching of the 2D objects. After sketching the 2D objects, we are going to create the part design. Okay, and then the wireframe and surface designs are also there, and then there is sheet metal design and assembly design and drafting. Okay, sheet metal design is nothing but we are going to create the sheet metals using the sheet metal commands by the usage of some sketcher tools. Okay, and then there is assembly design. We are going to create the assembly design of parts by using a number of parts we just already created. Okay, and then for drafting we will be creating the top view, front view, and the side views of it, and then this is the 2D drafting. Okay, these 2D draftings will be used for manufacturing operation. Okay, before the manufacturing of the product, 2D drafting should be done to the product, and then that 2D drafted drawings will be sent to the production department. For manufacturing a product, the documentation is a must. That documentation will be must have to be in the 2D format only. Okay, that is called a control copy. Okay, the control copy will be sent to each and every department, and the officers will be signing it, and then it will be converted into a control copy. That is the main product which we are going to produce, and then that control copy will be sent to the manufacturing department to start the manufacturing. Okay, the next thing we are going to see about is what are all the commands and toolbars we are going to see in the sketcher module. In the sketcher module, there is profile toolbar. Profile means the number of profiles can be created by using this profile toolbar. This is the profile option. This is the rectangular option. You can see a arrow mark right below the rectangular option. That is the number of face. Not only rectangle, a number of shapes can be created by using this command, and that number of face can be opened by using by clicking this icon. Okay, and then there is circle option. this is not the only circle option we have. A number of circle options are also there. A number of options are also there to create a circle. 3-point circle and a tritangent circle are also there. So that can be used to create, that commands are also can be used to create the circle by clicking this arrow mark. And then there is spline option and this ellipse, and there is a single line option. Okay, single line, infinite line, tangent line, number of options are there. So we can access that option by clicking this arrow mark, and there is the point option. Okay, number of options are also used to create a point, and then there is a center line option for creating a center line for revolving the object, and then also it can be used to mirror the object. Okay, there is operations toolbar. The operations toolbar can be used to a number of operations. Okay, that is the fillet, chamfer, and then trim option. There is symmetry option, mirror option, and translation and rotation option are also there. And then this is the project option. Okay, these options can be explained in detail when we enter into the software. Okay, and then there is constraints toolbar. Constraints is nothing but the dimensional. This is the geometry constraint toolbar. It is also called as constraints in dialog box. Okay, and this is simply called as constraint. This is the dimensional constraint of the sketcher module. And then this is the this is the fixed constraint, and this is changing the constraints. This is for changing the geometry constraint, and this is for changing the dimensional constraint. Okay, the next thing we are going to see about is the part design. The part design is application is used to create the solid models of parts. Okay, this is the main design we are going to use to convert the 2D models into 2D sketcher models into 3D models. Okay, solid parts are usually created from 2D profile that are extruded or revolved from a base feature. Okay, that is the base feature means to the base which we have drawn as a rectangle or else a circle. If you draw a rectangle and then extrude it, means it is going to become a cube or else a cuboid. Okay, if you want to revolve, means if you have drawn a circle and then extrude it, means it will be going to be a hollow cylinder or else a solid cylinder. Okay, parts can be modified by selecting their features in the specification tree. Okay, this we have already seen in the first slide itself. And then tools in part design. What all we are going to see about what are all the tools in the part design thing. Okay, these are all the sketch based features. The sketch based features are the this is the pad operation, this is the pocket operation, this is the shaft operation, this is the slot operation, this is hole operation, and this is called the rib operation, this is the groove operation, and this one is the multi-section solid operation, this is the solid combine operation. All those things we will be discussing in detail when we enter into the software. Okay, this is the dress up features. This is simply nothing but dress up features means simply nothing but the editing features of the sketch based features. Okay, editing features of the solids. Okay, here we are also having the solid fillet and solid chamfer. Okay, and a number of methods can be used to create a solid fillet, and also there is a draft, shell, and then this is thicken operation, and this is the thread operation. It can be used to create threads around a shaft. Okay, the next thing we are going to see is the transformation features. Transformation means we are going to transform the object, like moving the object or else rotating the object or else mirroring the object. This is the transformation feature. This is translation. This is the nothing but the movement operation, and this is the mirror operation. And also in this if you click this icon, means it can have a rotation operation also. And there is pattern operation. Pattern means we are going to create a number of objects by using this object only. Okay, and then this is the pattern operation. Then the pattern has a number of options. There is rectangular pattern, circular pattern, and user pattern. 3 types of pattern are also there. Okay, and then for entering into the assembly design, we are going to see about the assembly. Okay, the assembly design is application allows you to create a product model from a number of separate parts. What are all the parts we need? What are all the parts we need? We will be drawing that all the parts, and then getting it into the assembly design. We will be assembling the parts together according to their movement. Okay, according to their constraints and movements. Okay, the parts in the product parts in a product assembly are not joined together, but assembled as they would be in physical assembly. Okay, they cannot be assembled, but um, they will be fixed in such a way that it can be assembled in the real life. Okay, the product assembly structure is the hierarchical and allows you to model complex product relationships. Constraints can be applied between the parts in assembly to determine the relationship between them. Okay, and then moving on to the next thing, the assembly design. The toolbars in the assembly design are, these are all the constraint toolbar. Okay, this is the coincidence constraint, that is it is the axis coincident constraint, and this is the contact constraint, and this is the offset constraint, this is the angular constraint, and this one is fixed constraint, and this one is fixed together constraint, this one is temporary constraint, and this is the change constraint, and this is the reuse pattern option. Okay, and then this is the product structure tool. The first thing is the insert new component, where we if you use this means we are going to create a new component, and this is the insert new product option. New product means we are going to create a new product, that is new assembly product we are going to create. And the next thing is insert new part. New part means we are going to create a new part inside the product, in the product itself we are going to create a new part. And this one is the thing we are going to use very much frequently. We are going to use this one. This is the insert existing component. That means we are going to insert the component which we have already created. Okay, and then there is replace component. Replace component means we are going to replace one component with another component. In their place we are going to replace one component with another one. The step-by-step procedure for creating an assembly is: create a new CATIA product using file, new, and then product. In the file menu, we will be selecting new, and then we will be selecting the product in the dialog box. Okay, use the product structure tools to lay out the main assembly things. To create the main assembly things, use intersect existing component to insert new part. Okay, to create the geometry in assembly. To create the new part in assembly, to create the geometry in assembly. Okay, use constraints to capture the design relationship between the various parts of in the assembly. Okay, and then in wireframe toolbar we will be having in wireframe and surface structures we will be having create point wireframe toolbar, creating the points, creating lines, planes and projections and intersections, and then circles and splines and corners can be easily created. Okay, in surface toolbar we will be having extrude surfaces, surface of revolution, offset surfaces, sweep surfaces, and create filling surfaces. Okay, these types of commands we will be having. And then wireframe and in wireframe and the surface itself we will be having operations toolbar like joining, splitting and trimming and transformation. These in transformation toolbar we will be having translate. This is the translate option, this is the rotate option, this is the symmetry option, and this is the scale option. Okay, and then the next thing we will be going to the assembly of a real part. Okay, this is called a plumber block. This is one part, and this is another part. This is the block on the bottom side, and this is the block on the covering on the top side, and this is the assembly. This is a nut, and this is a locking nut. This is a normal fastening nut. This is the locking nut, and there is a hole for lubricating oil, and this is the casing which we going to house the shaft, and then there is a bolt inside here. That bolt will be inserted from the bottom. Okay, like this. This is the view and dimensions of the casting part. Okay, it is having a hole right from the bottom. So what they will be doing is they will insert a bolt from the bottom side, and the casing will be the top covering will be brought up here, and then it will be fastened. Okay, the next thing, this is the base sketch for creating the bottom of the plumber block. Okay, and then there is this is the base which we have drawn. Okay, and then this is the cap, and then this is the nut, bolt and lock nut. Okay, this is the fastening nut, this is the locking nut, and this is the bolt which we are going to use to bolt down the things. Okay, those two plumber block things, and this is the brasses which is going to house the that shaft inside the plumber block. Okay, that's all for today. I have inserted some of the playlist links in this video's description. Okay, you can find some playlist links in the description. Okay, do use that. There will be playlist for SolidWorks and ePlan, and if you want to learn the full course, means you can access our Udemy videos by clicking that link. Udemy, we have published a full course in the Udemy software, Udemy website itself. Okay, if you want to buy that full course, means you can use that and use that link, and it will be there will be some reduction for you. And then there is also some link for SSC, JE and other competitive exams playlist. Okay, please do share, subscribe and like our videos, and don't forget to click the bell icon. Okay guys, thank you. This is DCC. Have a nice day.